So for conditional probability, it's probability based on something that has happened before. So multiple events. So a lot of times it's organized in a box on a table like this. And so what I do when it's organized in a table, when you see a table like this, I add up each of the columns and each of the rows. And you notice that these numbers will add up to the same number as the sum of the column right here. So I go through and I add these, and it really helps me out answer these questions. So letter A, this means P, the probability an employee has less than a high school education. So there's 1205 people. How many people have less than a high school education? So what I would do is I'd count out people that make under $20,000 that have less than a high school education, people that make $20,000 to $30,000 that have less than a high school education, plus 2. So I'm going to add these up, which is 107. So I'm going to do 107 divided by the total, which is 1205. And then I can calculate that and round the nearest percent, and round the nearest tenth of a percent. And then letter B, employee earns under 20,000. So how many people earn under 20,000? Well, this whole column earns under 20,000. So I'm going to do 296 divided by 1205. C, employee earns over 30,000 and has less than a high school education. So where would earn over 30,000 but have less than a high school? Just 2. Not very high probability that somebody has less than a high school education and makes that much. And then D, employee earns under 20,000, has a college degree. Under 20 college degree is 13 out of 1205. And then given that employee has only a high school education, so you just want to start whatever you're given. This is a conditional probability. So given this condition, what's the probability? So given the employee has a high school education, so only counting these people, the probability that the employee earns over 30,000. So of these people, which is 224, is going to be your denominator. How many earn over 30,000? So that's 14 out of 224. And then letter F, given that the employee earns over 30,000, so you're only going to look at this column. So that's going to be 404 as a denominator. Given that the employee earns 30,000, what's the probability that the employee has only a high school education? So of this column right here, what's the probability they have only a high school education? So it's 14. So all of these, because the directions read to the round the nearest tenth of percent, I'm going to have to put these in my calculator and write them as a percent. Okay, so here's another situation of a chart like this. So I'm going to write down all of these. I'm going to calculate all the totals. Okay, so I added up all my totals, and remember that the sum of the column totals are is the same as the sum of the row count totals. So what this means right here is, what's the probability a student chooses sports as their favorite leisure activity given that they're female? So the condition is that they have to be female. So I always think about this as being my denominator. So the number of females is going to be my denominator. So total number of females is 334, as in the sum of this row. So I'm just going to pretend that's a denominator. And then the probability they like sports, is only the females, is 39. And then B, what's the probability they like that they're female given that they like sports? So you only look at the sports column because that's your denominator, and that's 106. And how many of them are female? 39. And then letter C, the male is a denominator, so 362. And then the reading is a numerator. So only look at the males that read that they're reading, because the condition is that they have to be male. So 76. I'll do a couple more. So what's the probability that they're male given that they chose reading? So you only look at the ones that chose reading. So the denominator is 161. and the numerator is of those that chose reading, how many are male? So that's 76. So see how these two are the same, they look like the same, but remember the denominator is going to be the total number of males, and then you only look at the males that picked reading. So the formula, if you don't have a table for conditional probability, is the probability of A, given B is the probability of A and B, so A and B happening at the same time, times the probability of B. So an example would be the probability that it's raining given that it's 70 degrees or higher. So for example, what you would do is you'd have the probability that it's raining and 70 degrees or higher times the probability that 70 degrees or higher. So A stands for the event that it's raining and B stands for the event that it's 70 degrees or higher, greater. So 3, the senior class is 55% female and 32% of the females play a competitive sport. Find the probability that a student plays a competitive sport given that they are female. So this would be student plays a competitive sport, A, given that the student is female, B. So it's going to be the probability that the student plays a competitive sport and they're female times the probability that the student is female. So if I read here, I can get from here that the probability a student is female is 55%, and the probability that a student is female and plays sports is 32%. So I'm just going to multiply 32% times 55%. So I use my calculator, 0.32 times 0.55 is 17.6%. So sometimes when it gets more complicated, when just those two, you can use a tree diagram. So there is a 70% chance of heavy fog and a 30% chance of light drizzle. A softball game has an 80% chance of being canceled for a light drizzle and a 30% chance of being canceled for a heavy fog when there is no drizzle. So I think about this as you can have fog and you can have light drizzle. So the chance that there's fog is 70%. And there's a 30% chance of light drizzle. So there can be canceled. So cancel, not cancel. So it could be, if the softball game has an 80% chance of being canceled for light drizzle, then cancel, not canceled. This would be 80% canceled. So that means that if it has a light drizzle, there's a 20% chance it's not going to be canceled. And then if it has a 30% chance of being canceled for fog, I'm going to put 30% right here, so it has a 70% chance of not being canceled. So you can use your tree diagram by doing, find the probability there will be light drizzle and the game will not be canceled. So you're going to multiply the probability that is B times A, or A times B is 20%, but then you have to multiply it by the chance that it drizzled to begin with. So it's going to be 20% times 30%. So you can think of, find the probability there will be a light drizzle and the game will be not be canceled. So find the probability that if there's a light, that the game will be canceled given that it's a light drizzle. That's why you're multiplying it by the light drizzle, 30%. So you do 0.2 times 0.3 and you get 6%. Find the probability that the game will be canceled. So what I'm going to do is I'm going to find the probability it's canceled due to fog plus the probability it's canceled due to light drizzle. So I'm going to multiply 30% times 70% and get that, and then multiply 30% times 20% and get that, and I'm going to add them. So this one is 21% chance, and the other one is 6% chance. So what's the probability it will be canceled is you're going to add these two together is 27% chance. And then number 5, the students at a high school are 51% males, or 51% males. So then we have 49% females, and 45% of the males attend concerts. So that means that 55% no concerts. So 45% of these go to concerts, and 55% of these don't go to concerts. 49% of the females attend concerts. So 49% of females attend concerts, so that means that 51% of the females don't attend concerts. So find the probability that a student is female and does not attend concerts. So I'm going to find the probability that a student is female and attends concerts. So that would be this one right here. So it's 0.49 times 0.49. Oh, does not attend. So it's 0.49 times 0.51. And it's 25% roughly. And then C, find the probability that a student attends concerts. So I'm going to do the concerts. I'm going to add these two up. So I'm going to do 51% times 45%. So 51% times 45%. And I'm going to add it to 49% times 49%. So there's a 47% chance that a student at that high school attends concerts.